Good day, everyone, and welcome. Today, we delve into the intriguing world of large language models with our research titled Fine-Tuning versus Retrieval Augmented Generation for Less Popular Knowledge. We, Haydar Soudani, Evangelos Kanoulis, and Fege Hasibi, explore how to enhance question-answering performance by comparing two key approaches, Retrieval Augmented Generation and Fine-Tuning. Stay tuned as we unravel the challenges, our unique solutions, and the significant implications of our findings. Let's embark on this journey together. The primary objective of this research is to enhance the performance of question-answering systems using two strategies, Retrieval Augmented Generation, or RAG, and Fine-Tuning, or FT. In the RAG approach, we employ various retrieval models, including BM25, Contriever, DPR, and a two-stage re-ranker. We've adopted an ideal retrieval setup, where we consider the summary paragraph of the Wikipedia page for the entity mentioned in the question. On the other hand, the Ford approach involves generating training data using two distinct methods, the end-to-end approach, or E2E, and the prompt method. We then fine-tune FLANT5 models using two techniques, full parameter tuning and parameter-efficient fine-tuning, or PEFT. These strategies aim to adapt large language models to specific domains, particularly in scenarios where the knowledge is less popular and limited data is available. As we delve into the heart of our research, we focus on two primary strategies to enhance the performance of question-answering systems, Retrieval Augmented Generation, or RAG, and Fine-Tuning, or FT. These methods are particularly crucial when we aim to integrate less popular factual knowledge into large language models. Now, let's take a moment to observe the figure displayed here. It illustrates the correlation between the popularity of a subject entity and the effects of RAG, and featuring on the performance of FLANT5 small and open domain question answering. What stands out is how fine-tuning significantly boosts accuracy in the initial and final buckets. This highlights the profound impact of the proposed methods on model performance, especially for entities that are less frequently encountered. In essence, our research is about improving the way we handle less popular knowledge in QA systems, and the results so far are promising. In our research, we grappled with several challenges. Firstly, we had to retrieve relevant passages for the RAG approach. Secondly, we faced limitations with the E2E method, particularly in controlling the quality and quantity of generated samples. Lastly, we recognize the importance of data availability for fine-tuning in specialized domains. These challenges hold significant implications. For instance, the quality of QA pairs can be limited by the T5 model's input token limitation. Additionally, we encountered practical challenges of direct counting and limitations of existing retrieval models. To address these issues, we proposed several solutions. We implemented an ideal retrieval setup for RAG, where we considered the summary paragraph of the Wikipedia page. We also applied zero-shot prompting for generative prediction. Furthermore, we experimented with three sizes of the FLANT5 model to examine the impact of model scale on performance. These solutions aim to enhance the quality of our QA generation and retrieval processes. In our research, we focus on two main approaches to fine-tuning large language models. The first involves generating training data using two distinct methods, the end-to-end approach and the prompt method. The end-to-end approach utilizes a model specifically trained for paragraph-level question-answer generation, while the prompt method generates synthetic training data by prompting a large language model. The second part of our fine-tuning approach involves the use of FLANT5 models. We fine-tune these models using two techniques, full parameter tuning and parameter-efficient fine-tuning, or PEFT. Full parameter tuning involves adjusting all the parameters of the model, while PEFT is a more resource-efficient method that adjusts only a subset of the parameters. Together, these methods allow us to adapt large language models to specific domains, enhancing their performance and making them more effective for industry-specific applications. In our research, we primarily focus on two approaches, Retrieval Augmented Generation, or RAG, and Fine-Tuning, or FT. Let's delve into the RAG approach first. We employ a variety of retrieval models, such as BM25, Contriever, DPR, and a two-stage re-ranker. These models help us fetch the most relevant passages for our task. Our ideal retrieval setup considers the summary paragraph of the Wikipedia page for the entity mentioned in the question. Once we have the relevant passage, we apply zero-shot prompting for generative prediction. To understand the impact of model scale on performance, we experiment with three sizes of the FLANT5 model: small, base, and large. This comprehensive approach allows us to effectively adapt large language models to specific domains. In our research, we delve into the technical details of the fine-tuning approach. We generate training data using two distinct methods. The first is the end-to-end approach, which employs a model trained for paragraph-level question-answer generation, specifically the T5 model. The second method, known as the prompt method, generates synthetic training data by prompting a large language model, utilizing a tool called Zephyr. Once we have our training data, we fine-tune the FLANT5 models using two approaches. The first is full parameter tuning, which adjusts all parameters of the model. The second is a more efficient method known as parameter efficient fine-tuning, or PEFT. Among various PEFT techniques, we chose to use QLOORA, which is widely accepted in the field and makes efficient use of computational resources. These methods and techniques form the backbone of our research, allowing us to generate high-quality question-answer pairs for our study. Our research introduces key improvements and innovations in the field of question-answer generation. We address the challenge of retrieving the most relevant passages for the Retrieval Augmented Generation approach. By employing a variety of retrieval models, we ensure that the most pertinent information is used to answer the question at hand. We also tackle the limitations of the end-to-end method. While this method has shown superior performance, it has its drawbacks, such as limited control over the quality and quantity of generated samples. To overcome this, we also utilize the prompt method, which allows for more control and flexibility. Lastly, we optimize fine-tuning techniques for efficient use of computational resources. This is achieved through the use of the QLORA technique, which ensures that our models are not only effective, but also efficient. In essence, our research is a blend of innovative solutions and optimizations, aimed at improving the performance and efficiency of question-answer generation models. Diving into our key results, we found that the ideal retriever, which uses Wikipedia summaries, stands out in question-answering performance. This is a testament to the power of leveraging structured, high-quality information sources. Next, we observed that the scale of the FLANT5 model has a significant impact on performance. This underlines the importance of model size in achieving optimal results. In terms of methods, the end-to-end approach, despite its limitations, excels in question-answering tasks. This highlights the potential of this method in generating high-quality question-answer pairs. Lastly, we found that the QLORA technique is a game-changer in terms of computational efficiency when fine-tuning FLANT5 models. This finding is particularly important in the context of resource constraints, making the fine-tuning process more accessible and manageable. These results collectively provide valuable insights into the optimization of question-answering systems. As we draw our discussion to a close, let's take a moment to reflect on the key contributions of our research. We've conducted a comprehensive comparison of retrieval augmented generation and fine-tuning methods, aiming to enhance the performance of question-answering systems. Our investigation delved into various factors that could potentially affect performance, including model size, the choice of retrieval models, the quality of synthetic data, and the fine-tuning method employed. We've also demonstrated the effectiveness of using Wikipedia summary sections for passage retrieval and question-answer pair generation. This approach has proven to be particularly beneficial in the context of less popular knowledge, where limited data is available. On your left, you can see a figure that compares the accuracy of the RAG approach before and after fine-tuning across all relationships in the POPQA dataset. This visual representation underscores the significant improvements achieved through our methodology. In conclusion, our research provides valuable insights into the adaptation of large language models for industry-specific applications, particularly in less resource domains. We hope that our findings will guide future research in this field, contributing to the development of more efficient and effective question-answering systems.